Here we go. Arguments optional. The last challenge in the intermediate algorithms. This one involves knowledge of partially applied functions and a really good grasp of the concept of closures. So if you're not very familiar with those, especially the idea of closures, definitely research that a little bit on your own, try to understand that. Otherwise, you won't get too much from this walkthrough. It's definitely a bit more of an advanced walkthrough, and to really get some meaning out of it, you need to learn these things as a prerequisite. Otherwise, you're not doing yourself any service just by looking at this and getting the answer. So assuming that fundamental knowledge of closures and maybe a vague knowledge of partially applied functions is under your belt, let's start by looking at the first type check, where it says somewhere here that we want to return undefined if we don't get an actual number. Right here, yeah. If either argument isn't a valid number, return undefined. So let's make a check for that first and foremost. We want to find what the arguments are, and since, as the title implies, some arguments are optional, sometimes it's invoked with 2 arguments, sometimes it's invoked with 1, and then invokes the return of that with another one. So we want to account for any number of arguments. Accurately so, there is no formal parameters declared because we don't really know what we want to use for that. So we will be using the arguments object, which is also something you should have a solid knowledge of. I'll declare it here. I will use an array literal to get the slice method. It will go up the prototype chain to, the array.prototype, but it's a little cleaner. It's a little shorter as a line, so I kind of like that. So I'm going to use that this time. Array.slice.call arguments, which will convert the number of arguments we have into an array. Then let's use an array method to check that each argument is a type of number. Otherwise, if it's not, we're just going to return undefined, right? So we will have args, and we're going to use this one called .every. And this will take an anonymous function that will pass, I will call it an argument because it's looking at each argument. And we're going to return type of argument is equal to number. So right now we have, if every single thing in here is a number, we return true. We want to trigger this only if that is not true. So if one of this is not number, then this returns false. We're going to negate this so it triggers for a false statement. Once we have that, get rid of the semicolon. Inside this block, we will just return undefined. So let's try running this right now. As you can see, we are passing our specs for undefined. That looks good. We are not passing this one because we have not actually returned a function here that then invokes this. We are returning undefined, and then it's trying to invoke undefined with this, which it gets in error. So that's okay that this is not passing just yet. We want to address these first, though. So add 2 and 3 should return 5. Otherwise, if it's only 1, it wants to return a function. When it is invoked again, that function should add 3 to this already declared argument from another land and another time. So to do that, we want to first, let's look at this right here. Add 2 and 3. How do we know that this case is, that we are in this case if we have 2 arguments? We just check the args variable. So if args.length is equal to 2, then we just want to return those added together. That's the base case, that's the standard add functionality. Let's return args index 0 plus args index 1, right? And let's run this. That gets a pass. That is not too special in and of itself. This is where things get a little bit tricky. This is basically asking for a function that returns a function that can be invoked again. That's how this is working. It's basically chaining function invocations the same way we can, chain, like we can chain something like that, dot reverse, dot, dot split. It's the same idea, but we're using function invocations. So this would apply if we don't have two arguments, in this case if we only have one argument. So I'm just going to make it an else statement. That will suffice for this. And we want to remember this argument here for the function that gets returned here. That's the idea of the partially applied function. And we're going to put this in a closure, so let's declare the things we want to keep before we start writing the function that's going to get access to this. That's the idea of a closure, is you always want to declare first and foremost. It's like taking inventory. It's like saying, I'm putting this briefcase on a flight and I want us to remember this is mine for when we get into another land. So what are we declaring? I'm going to call it A, and what we want to keep is that first argument, args of 0. Because right here we have one argument being passed, we want to remember this too. So now this is saying we will remember this. Now we're going to make a function that will make use of that declared argument. I'm going to call it add1, because we're essentially returning a function that adds only one more argument. So we will set this to an anonymous function, and B, this is going to be the missing argument. This is going to be here. Since we're returning this after we return this stuff, the rest gets invoked with 3 right here, so that's what this is going to be used for. And in here, in this add1 function, we are going to return, and what do we want to return? We can use this a little recursively here. We are returning the add function again, and we want to get to here if another argument is passed through. So we can return add and pass in A and B. Now remember, what is A? A is what we've remembered right here with this first function. And then B is whatever the user will return on the second invocation here. So this is the new function that we want to give to them. So then once we've declared that, we are going to return that entire function. And I have a semicolon missing here, yep. So that once we return this function is going to take this argument and it's going to run the add function for us again, adding the first argument that it's already remembered and the one we are just passing. So this whole thing will run again, and now it has a full, complete 2 arguments. It will run this test again. This time the arguments will be equal to 2, and it will return the number value of these 2 numbers added together instead of making a partially applied function. Let's try running all that. And we're going to pump you up. Not as much as we pumped up that partially applied function, I would say. How did that go? That was it's a lot to digest. It's a pretty complicated concept. So it's worth talking about. I'd love to hear your thoughts on the idea of partially applied functions, how you are using it, what you've learned, what you'd still like to learn about it. It's a great concept to keep talking about. So definitely let's keep talking.